Hey there Internet people, I'm here again with another Unity tip. This time it's all about
going slow
and
speeding up
by using the Unity variable Time.timeScale. You may be using an approach similar to this to slow down and speed up your game objects, whereby a central variable is used to guide the frame rate. But this can have pitfalls such as the dependency on referencing a central game object or class, as well as the overhead of managing those references. This can lead to bugs, particularly if you forget to reference that class or game object. Using Time.timescale is a better way to achieve this effect globally within your game. Time.timescale can be used to adjust the rate at which real time passes within your game. Setting this to a value of 1 allows time to pass in real time. Setting this to a value of less than 1 slows down time. Setting this to a value greater than 1 speeds up time. Remember, this is a global setting, so it will affect anything in the scene that is dependent on time. Let's head over to Unity and work through an example. To demonstrate the usage of Time.timescale, we first need something visible on screen and moving. So let's initially create a game object. Now, we need to add a script to that game object to help make it move. Let's open that script up. As we want this game object to remain visible on screen at all times, we're going to need to control its movement by using a variable that we can flip between negative and positive to change direction. So let's first create that. Then to move the object, we're going to use transform.translate. To ensure the movement rate is controlled on a per second basis, we need to multiply the vector we're passing in to transform.translate by Time.deltatime. Then, to keep our game objects on screen, we add an if statement that controls the range our object moves by comparing the transform.position.x with fixed values. And if those values are exceeded, we flip our movement variable between positive and negative. After compiling, let's go and test our script within Unity. And there we go, we have a controlled range of movement that allows the object to remain visible at all times. Now let's go and make use of Time.timescale back in our script. To allow us to adjust how time passes during play, we'll first need to make a public float variable and set it to 1, in other words, real time. Within our update method, we will set Time.timescale to equal the public variable we just created. And that's it. Let's compile and head back over to Unity. Ensuring we've selected our game object so that our public variable is visible to us in the inspector, click play. If we set our public value to a value lower than 1, our gameplay will slow down. And now if we set our public variable to a value higher than 1, the gameplay speeds up. Nice and simple. As a side note, in practice it would be good to ensure that you store the initial time.fixed_deltatime variable value to restore how time passes back to its original speed. In a real situation, how is this used? So we've all seen games where play slows down, such as in games like Superhot VR, and in Red Dead Redemption 2, the Deadeye effect will be utilising a similar approach, as well as in the Max Payne series, Bullet Time will be using exactly this. An easy yet powerful feature within Unity, wouldn't you agree? I really hope that this Unity tip was useful to you. If you like this video, please click like and don't forget to subscribe and click the bell to get notifications of my future videos. If you have any questions, you can get in touch with me via Twitter or in the comments below. You can also catch me on Twitch streaming game development content mixed with gaming on a regular basis, so why not head over via the link in the description and follow me so you can pop by and chat when I'm next streaming. Thank you for watching.
Thank you.